As we continue in our booklet, on page 68, we're asked to classify these functions. Now, when we see that the exponent is the variable, these are exponential functions. So you would put a check by exponential. Now, as you look at number 2, here our variable is actually part of the numbers of the function, and it's to the first degree. There's a 1 that's unwritten by the z, so this would be linear. In number 3, since our exponent is a number and it's to the second degree, that is x to the second, this is quadratic. In number 4, notice the exponent is the variable, so this would be exponential. And here we see the exponent is a variable, so this would be exponential. So something relatively easy as long as you know the parameters for classification. As we move into page 69, I could put that right up there, I guess. We are asked to graph this exponential function. And the protocol that we'll follow throughout this is to make a little t-chart, put some values here, and then kind of get a sketch of, after we place our plotting points, what the curve would look like. So here we're going to use a -2, these points. So if I put a -2 there, and you may recall the rule, when it is a -2, you can flip this and make this a +2. So 2 to the second, this will be 4. Again, if it's 1/2 to the -1, you can flip that, make that a +1, and this is just 2. Now, anything to the 0 power is going to be 1. And then 1/2 to the first power is 1/2. 1/2 to the second power is 1/4. So we get a series of points that we're now going to plot. So after carefully plotting them, we see our curve that I can sketch in now. Looks like so. And you may note that our x-axis here, I didn't want to cross it, is our horizontal asymptote. That is, this line gets close but never reaches the x-axis. Following our strategy for number 2 now, we're going to create a little t-chart where we'll use those same values. And now where we have our x, we're going to substitute a -2. So -2 squared times 5 to the -2. So -2 squared is a +4, and 5 to the -2, just flip that, that's 1/25. This will give us then here 4/25. When we square a -1, we get a 1. And then this is 1/5. So this becomes 1/5. Now, when this is 0, now 0 squared is 0 times 5 to the 0 power is 1. 0 times 1 is 0. 1 squared is 1 times 5 to the first is 5. 1 times 5 is 5. 2 squared is 4. 5 squared is 25. 4 times 25 is 100. Now you see we have some points that are near our origin, and then it quickly goes off the scale, but they want us to sketch this. So we get a little curve here, but then it goes back down to 0, and then it shoots way up. In example 3, we'll follow the same procedure. Now notice there is a negative sign in front of the x. So when we put in our negative value for x, this is going to become a plus. So 4 to the second is 16, minus 3 is 13. This will become a positive. This will be 4, minus 3 is 1. If this is a 0, anything to the 0 power is 1. 1 minus 3 is 2. Now here, 4 to the negative 1 is 1/4. Minus 3 gives me a negative 2 3/4. Now 4 to the negative 2 is 1/16. Minus 3, this will be a negative 2 15/16. Now let's plot these points. So 13, negative 2, 13 is way up there. I kind of just guesstimated a point. Then negative 1, 1, so negative 1, 1. And then 0, negative 2. So we get a curve then. And again, you're just trying to sketch these to give you an idea what they will look like here. And I believe negative 3 is your horizontal asymptote. I went over the line a little. Now I think you have the pattern of what we're going to be doing. So for example 4, we make a t-chart, put in our x values, and then put them into this form. Now this is a negative exponent, and I just put this into my calculator. 3 caret, then I put this, negative 2 divided by 5, enter, and I get approximately 0.64. If I put a negative 1 there, I get approximately 0.80. Now if this is 0, anything to the 0 power is 1. And then if this is a positive 1 here, putting it into my calculator, I get this, and 2, I get this. And again, we just want to get the idea of what would the shape of this particular function look like. So something like that. Again, not a very steep thing because of the fraction nature of this. And it looks like our horizontal asymptote is going to be your x-axis here. As we look at page 70, they get a little more challenging. Part of it is to, of course, read the example very carefully. And then what do they want? And here they're saying that the total revenue of water bottle sales since the year 2000 are approximated by this function, where it's exponential because t is the exponent. And we're saying that t is greater or equal to 3. Now, where t here will correspond to 2003. So t here is 2003, or 3. So they want you to find the revenues for 2005. So the question is, what will this t be here? And if T3 is for 2003, then this one will be for the 5th. And then here for 2009, this T will be to the 9th. So you put this times this caret to the 5th, and I think your calculator will take care of that. Otherwise you could do this to the 5th and then times it by this, and your answer comes out 103.9, and keep in mind this is in millions of dollars. And this one, and again you want to check this on your calculator, and the answers are on page 81. Now I looked at this, and there is a protocol for it, and I'm going to skip this one temporarily here because the answer I got wasn't quite in agreement, so I want to be sure I don't give bad information. Okay, so in example 3 now, once again, they're giving us a formula, this, and where WO is the symbolism for the initial amount when you started off. And they're saying that initial amount in the year 2000 was 5,680 megawatts. So that's what we're going to put there for the WO. And then this is part of the formula, 1.95. But now what will our value of T be? Well, T to the 0 power, when T is 0, it is the year 2000. So if T is 0 at 2000, what do you think it's going to be at 2004? And if you said to the 4th, that is correct. And you're going to write this same thing again. Let me do it for you. What will you use for 2006? Well, the 6. And then when you do that, you get your answer. And this will give you some practice on your calculator. So part of it is understanding what does the formula say, and then interpreting and where to put your values. In example 4, again, the number of words per minute that an average person can type is given by this function, which I've written out here, where T is the number of months after having beginning a typing class. Now, find when T is 0, T is 2 months, and T is 5 months. So, we do some substitution here. We want it for 0 months. So if I put a 0 where the T is, this becomes 0. So we're saying e to the 0 power. Well, what if we said anything to the 0 power is what? 1. So this will be minus 28. And then this will give us 37. So at the beginning, after some lessons, apparently you can type 37 words per minute. Now, how about if this T now is a 2? Well, what I'm going to do here is put a 2 there, and 0.4 times 2 is 0.8, which is what I'm going to use now. So I will put 65 in my calculator, minus 28, then I will type in E, and I will go caret, and then I will put this in parentheses, a negative 0.8, hit enter, and again you should be trying this, and you should get 52 words per minute after 2 months. And if you put a 5 there, 0.4 times 5, that is for your time here, negative 0.4 times 5, this will give you a negative 2, that you'll put this, but here in parentheses a negative 2 for this third case when it's a 5, that will give you 61 words per minute. Okay, now this next one, I had some questions about it too, so I will check. I'm going to just postpone doing this one, and of course you can check with your tutors locally to get some help.